Hello, my name is Lance Morris. We're going to have a webinar today to talk about the cohesive RCM extension for Maximo. Just a little bit of background about cohesive. We have a deep grounding in Maximo as an enabling technology. We also hire experienced individuals from the business that can identify the business requirements and apply the technology to enable those requirements to be met through business practices and processes. So our focus is on the process definition and then using that industry experience to use the enabling technologies to satisfy the business requirements. A little bit of my background, I am a mechanical engineer by degree. I started out in the power generation industry, worked there for several years, and then transitioned to implementing work and asset management systems approximately about 28 years ago now. So jumping in, the definition of reliability-centered maintenance. If you asked 10 maintenance professionals to define RCM, you'd probably get 10 different answers. What we tried to do in this configuration was boil it down to some of the important key attributes of those definitions. So identify what's important and why, identify what can go wrong with those things that are important and what the consequences of those are. That identifies your risk, and then identify what can be done to prevent or mitigate that risk, and what expenses you're willing to take on to mitigate the risk, and then apply continuous improvement techniques to monitor the effectiveness of your measures and improvements. Applying those principles to Maximo. Maximo is a work and asset management system. So applying those principles to the components that are in Maximo boils down to, let's identify what equipment is important and what makes it important. Let's identify how it fails and what the resulting consequences of that failure are. And let's identify what we're willing to do to prevent or mitigate the risk of that failure occurring. And then use the different modules to capture and automatically route feedback on the effectiveness of those actions and what improvements we need to make from a continuous improvement perspective. RCM is kind of the pinnacle of your maintenance maturity model. Looking at the model, you start out as reactive maintenance, and then you get into some planned or scheduled preventative maintenance, graduating up to condition-based maintenance and predictive maintenance, and then finally graduating to RCM, reliability-centered maintenance. But boiling it down, it's basically doing the right things to the right equipment at the right time. So in Maximo, defining what is important and why, we should understand and capture the design function of the operating location. I'm going to use the term operating location throughout the presentation, but in the configuration, we've applied the same principles to the assets. So if a customer is more focused on the asset rather than operating location, that's supported as well. So in order to do that, we need to understand how critical the operating location is to the process. And if it is critical or important, how does it fail and what are the consequences of those failures occurring? And then what other considerations might affect the performance of the equipment. We'll talk about that a little more later. So as part of a configuration in Maximo, it's not a standalone application. What we've done is extended some of the objects in Maximo and then used relationships to display related data where needed. So as you'll see here, we've extended the locations and in this case, the assets application as well. We've added a couple of new tabs to pull some of the information from different modules within Maximo and put it together in a format that makes sense from a reliability-centered maintenance standpoint. And as part of that, we're leveraging the capabilities of the Master PM and the Preventive Maintenance module. We're also using the work order module to capture that feedback and for continuous improvement. All of this is configuration. There is no customization, so it should easily upgrade with the IBM upgrade tools for Maximo. So as I mentioned, we had extended the location and the assets application. The screenshots from the location. We've added a couple of new tabs. The first one here is RCM FMEA for failure modes effects analysis. You can see in the header portion of the screen, we've added a few fields. The first one is a design function to capture what the function of this location is to the process and to the system. We will leverage the failure class that comes in base Maximo. We've relabeled the priority field to be criticality and added a domain behind it. Typically, we try to keep it to 3 values: critical, important, and run to failure. The codes are typically 1, 5, and 10 to allow you to add more if you need. There are a couple other fields that capture the context that we'll get into deeper a little later, but one is the environment. What kind of environment is the equipment operating in? And duty cycle, whether it operates continuously only in emergencies or rotates 2 out of 3 or 1 out of 2, just how it gives a loading of how the equipment is operated. In the center part of the screen, we have what are called problem modes and effects, or failure modes and effects. So based on the failure class, we can identify which problem codes apply to this component. And then for each problem code, we can identify the consequences of what happens if that problem occurs. We can identify if it's a functional failure, if it prevents it from fulfilling its design function defined above. And then we can also identify if it involves personnel safety or environmental factors. The bottom part of the screen is the maintenance strategy for what we're going to do to try to prevent or detect a problem code from occurring. So as it comes configured out of the box, the maintenance strategy listed below is specific to the problem code selected above. So if we change the cursor to low pressure instead of leak, we would see potentially different PMs listed in the maintenance strategy for that. This is the detailed section of the center part of the previous screen, the failure modes and effects analysis. There are a few extra fields here. We've added a couple of fields in the lower right to capture basically the dollar impact on production if this failure occurs, and the dollar impact to repair if this failure occurs. Occasionally, we do have repairs that are very costly to do, but may not have a big impact on production. So again, I'm trying to identify the risk from a financial perspective. The lower part of the screen on the left, we've added a field for job plan, and the intent of the job plan field is to identify what job plan would be used to repair this problem code if it were to occur. The idea there is to close the loop with parts and inventory management. So if the job plan has a certain set of parts that are needed to repair this problem code, we can make that visible on the inventory side as we're evaluating our order points and order quantities and how much to keep on hand. If we know a part is tied to a job plan that is linked to a functional failure against a critical asset, it may have a higher importance that we keep a different level of safety stock than something that's not tied to repairing a functional failure on a critical or important location or asset. The bottom part of the screen with the maintenance strategy, this is opening up the details. Basically, this is just showing you information from the PM. The key field, all these fields are out of the box except for the strategy description. So we added a strategy description to basically text describe how this PM is intended to detect or prevent this particular failure or problem code from occurring. So jumping over to where that data came from, we've moved over to the preventive maintenance application now. And you can see that we've added an RCM tab to the PM module. We've added a couple of fields in the center of the screen there to identify the basis for why we're doing this PM and the basis for why we're doing it at the frequency that we set it up as. So this again provides more background to the next person that may be looking at or evaluating this PM as to why we're doing it and why we're doing it at the frequency we're doing it at. The lower part of the screen is the problem codes that are linked to this PM. So this particular PM is intended to detect or prevent the leak problem code as well as the low pressure problem code from occurring. And then down at the bottom, you can see that description is that strategy description that we were looking at on the location screen earlier. As we design the configuration, you might be thinking, well, that's a lot of work to go through and identify a criticality on all of my locations and then go through each problem code and identify the consequences and all the other data. So we wanted to try to provide a more streamlined or grouping type approach to allow people to kind of grow into the more detailed approach if needed. So we came up with a streamlined approach, and it leverages the master PM module that's in Maximo. So if we jump over to the master PM module, we've added some fields to the master PM, one being the failure class over on the right-hand side to identify the type of components that this PM is intended for. Then in the center part of the upper part of the screen, we've added criticality with the same drop-down that we saw on the locations and assets. We also added that environment and duty cycle fields to the screen. So what this is intended to do is once we identify an asset or location, we identify its criticality, its environment and duty cycle, as well as its failure class. It will come up with a list of master PMs that meet that criteria, and that becomes the recommended maintenance strategy for that type of component in that context. In this case, you can see that the environment and duty cycle are blank, so that would mean that this particular PM would be applicable to any critical pump, regardless of its environment or duty cycle. If it only applied to, or if I had a different frequency based on what environment it was operated in or what duty cycle it was operated under, we could just duplicate this master PM and update that frequency for that particular type of scenario. As I mentioned, we leveraged all this back on the additional tab on the location and asset called RCM Stream for Streamlined. You can see we still got the design function, criticality, environment, and duty cycle. But once we've identified the failure class, criticality, environment, and duty cycle, a relationship in Maximo performs that query and populates the table window in the center of the screen with the recommended maintenance strategy. So in this case, for this type of pump operated in this scenario, there are 3 recommended PMs. Down at the bottom part of the screen shows the actual PMs that are associated to the component, and we can see which ones are linked to the master PM. So we can quickly take a look and see that all of our recommended maintenance strategies are currently covered by current PMs. I can also see that there are extra PMs down there. So that kind of leads me to some of my PM reconciliation and PM optimization as to what are the basis of those PMs and should they apply to others? And that's part of the cleanup as we go through this process. The other benefit we get from using the master PM, and we'll cover this a little more when we get into some of the feedback, is if, let's say, for example, in a particular facility, I had 200 480 volt breakers, and I had an annual PM that I performed on those breakers. As I perform those PMs, I'm capturing the as-found condition of the component when I do the PM. And what I may find out over time is they're always in superior condition. So that tells me I can extend the frequency of that PM from maybe 12 months to 24 months. Rather than having to go update 200 PMs, if they're all linked to their master PM for strategy, I can go and update the frequency on the master PM and have it push out to all the implementing PMs. So it makes update of the strategy a lot more streamlined. Now I'll transition to capturing the continuous feedback and improvements. We're capturing all this information on the work order. So we wanted to capture the details of what work was performed and have it done in a specific manner to make it easier to search. We offer the opportunity to provide feedback on the quality of the planning process and what needs to be changed in the job plan for future performances. We also, for preventive maintenance, as I mentioned, we're putting in the ability to capture an as-found condition of the component for trending purposes. And we can also provide further feedback on scope and frequency changes that may be suggested. If it was a corrective maintenance on a non-run to failure component, then we gather feedback trying to determine if it was a maintenance preventable functional failure and what we could have done to prevent it. And I said non-run to failure component because if the maintenance strategy or the criticality of the components run to failure, then I eventually expect to have a failure. So it doesn't necessarily make sense to capture feedback on whether I wanted to prevent that or not, since that was my strategy going in. But the process, as I mentioned, we focus heavily on the process. The process is as important as the technology. So once that feedback is captured, it needs to be dispositioned. So each plant and facility can have their own setup, their own routing based on their organization needs and how they're set up. But the key is we're using push actions through escalations and workflows to push things that need to be evaluated or looked at versus having to run reports and look for things. We also use the same strategy to bootstrap or build missing data that may need to be built out, such as criticality codes or failure modes and effects analysis. And finally, providing continuous improvement accountability. So a lot of people have planning feedback forms on their work orders, but once a craft person fills one of those out, submits it, and then the next time they go do the job, it's still the same. They lose faith and quit filling out those forms. So at least in our model, there is some accountability to understand what happened with that feedback that you submitted earlier. So now we transition to the work order screen. We've taken what was the failure tab and relabeled it as post-work. If you look down at the bottom right, what we've done is moved the failure reporting that was originally there down to a sub-tab on this screen. So up in the header, we've added a couple of new fields. One is a completion code, and we put a domain list behind that with values such as completed as planned, or completed with additional scope, or completed with less scope, or in some cases you may be completing it with no work performed. So those are some of the typical values you would see in that drop down. Just below that, we have a text field to basically capture a summary of the actual work performed. So this gives us a specific field to do searches for keywords and look for specific information versus having to dig through several log notes that may be in the log tab. Down in the bottom section for the webinar, I've got all the tabs enabled, but typically you would always see the planning feedback and the failure reporting tabs. The other two tabs we typically hide based on the conditional UI. So if it was not generated from a preventive maintenance record, the preventive feedback would not be displayed. And if it was not a corrective maintenance work order against a critical or important location or asset, then the corrective feedback tab would not be displayed. So now going through those tabs one by one, the planning feedback tab, if we add a planning feedback, it captures a feedback ID created by date. We have a type code so that we can type the feedback. Typical types would be update the work instructions, update the material list, update permit requirements, coordination. They're user defined as to how you want to type your feedback. And then the recommendation is the textual description of what improvement they're requesting. It is status control. Typically, it would be assigned to the planner and given some due date, but this is where we get that accountability. So in some cases where a craft person might make a recommendation to change some of the work instructions or permitting, there may be regulations they're not aware of that require us to do it that way. So in the actions taken, we can describe that, hey, it's a good idea, but because of this, we can't do that. So at least they get feedback and accountability that somebody evaluated their recommendation and took some action. We also have had some customers that have built out a specific application for the planning feedback. So even though it can be initiated directly from the work order, it can be workflowed and routed via its own specific application for disposition. Now looking at the corrective feedback subtab, now we've leveraged that design function that we saw on the location and asset FMEA and RCM Streamline tabs. So it's read-only, but it's provided as information to the end user as to what the function of the component was from a design perspective. And then we just ask simple questions. Did the equipment fail to meet its design function? So did the failure prevent it from doing what is listed above? And if so, could the failure have been prevented? And those are just simple yes, no's to try to determine if it was a maintenance preventable functional failure. And then we have a text field to identify suggestions as what we could do to prevent the failure from occurring. On the preventative feedback, we've added a couple of extra fields as well as displaying information from the PM. So up at the top, we're displaying that basis for the PM and the basis for the frequency. And down at the bottom, we're displaying the failure modes that are intended to be addressed by the PM and that strategy description of how the PM is intended to affect that problem code. In the center of the screen is where we're capturing our feedback. First field there is a as found condition, and we typically put a domain behind that. I've seen it as few as 3 choices to as many as 8 or 10 choices. But typically you want to kind of keep it simple. And then again, we just ask a couple of questions. Was the PM adequate based on the basis and the failure modes and strategy descriptions? And was the frequency okay? If either of those said yes, then we could put in textual description of what we suggest to improve the PM going forward, that continuous improvement. Now that we've put the framework together to capture that information, now the last step is to build a process around how we disposition and route it for evaluation. So we typically use escalations and workflows to do that. Again, this feedback can be used to build the foundational data that might be missing, and also used to track that feedback and the response to that feedback. We can also use escalations to mine the data for anomalies that were not expected. So one example we'll cover in just a second when we look at some of the workflow examples. So this is just a screen to show you the inbox assignments that come from all different areas of Maximo, but we're going to specifically look at those around the RCM continuous improvement. So the first one highlighted there is what we described as building out your foundational data. So in this case, we've had a couple of different work orders against a couple of different locations. They're corrective maintenance work orders, so their work type was CM. They've been completed, but the locations or assets that they were written against did not have a criticality or priority assigned to them. So we're pushing that out to someone, whoever is responsible for that, to assign a criticality to them going forward. This is typical of what we recommend coming in. We run into a lot of examples where customers will put together a significant project to go through and assign a criticality to all their locations, even though 70 to 80% of the locations have never had a work order written against them to utilize that information. So using the escalations, we kind of focus our efforts on the 20% of the locations that cause 80% of our work up front and get the best bang for our investment. The next one is building out that failure modes and effects table. So in this case, these work orders were written against a critical or important location or asset, and the work order identified a problem code that did not show up in that FMEA table window. So nobody has to date evaluated that problem code for its consequences and if there is a maintenance strategy that needs to be associated to it. So again, we're pushing that out to kind of build and bootstrap that FMEA build out based on what happens in the field, applying the 80-20 rule. This is the example I talked about anomalies. So in this case, work order 40093 was written against a critical or important location. That location had a problem code identified in the FMEA table for low volume. It also had PMs related to it to help detect or prevent it, but yet we still had a corrective maintenance work order completed on that location with that problem code identified. So our maintenance strategy did not do what we expected it to do. So now we're pushing that out to someone to evaluate our strategy, and is our strategy adequate or do we need to update it? Finally, at the bottom are just those suggestions for improving the PM. So if someone filled in a suggestion for a change to a PM, then we're routing that to the PM coordinator to evaluate updates. So some considerations that we can use once we get this model built out is, are you performing the right PMs? So again, linking your PMs to critical or important assets and problem codes helps you close that loop to understand why you're making the investment in that PM. And once you get all those links built out, the PMs you have left over, those are the ones you go back and question, why am I doing them? What is the payback for the investment of doing those PMs? And same thing with the frequency. And are you capturing meaningful knowledge regarding the asset or equipment from the personnel that worked on the asset, the people that had their hands on it? So in this case, we're trying to set up the work order so that the people that are completing the work can provide that direct feedback on what they saw when they were in the field. And can that data be easily searched? You saw as we set up the separate work completion summary to allow it better searching for keywords rather than digging through logs. And then how do you prioritize the missing or foundational data? Again, we talked about that with escalations, being able to apply the 80-20 rule to help us get the biggest bang for the buck as we focus our resources to build out the data. So in summary, Cohesive has helped organizations improve their equipment reliability by merging processes and leading practices with the technology that's in Maximo. And again, it's set up to give you a process of continuous improvement and build out so that you don't have to eat the elephant all at once. You can apply the 80-20 rule and grow and continue to improve without having to put together a major project to try to build out all the data necessary for a complete RCM program. You can kind of grow into it. So for inquiries and references, there's information on our website regarding the extension for RCM. There's some blogs. There's my contact information as well as our website. And then our safe harbor for general use.